This video is on Hess's law. So Hess's law talks about in going from a set of reactants to a set of products, the change in enthalpy is the same whether the reaction takes place in one step or a series of steps. So enthalpy is a state function. It's independent of the pathway. What this means is that if I were to hike up this mountain and I were to go from here to here, or if I were to take the switchbacks and go here and then get to the top, in both instances my reactants where I start and my products where I end are the same distance away, but the path to I get there doesn't change where I end up. So as long as we know the series of steps, we can figure out the total enthalpy for a reaction. So if I were to look at the reaction of nitrogen and oxygen to make nitrogen dioxide, and I wanted to figure out my change in enthalpy for that reaction, well, I could look up to find out that this reaction takes place in two steps. My first step is my nitrogen and my oxygen combine to make nitrogen monoxide, and then my nitrogen monoxide combines with oxygen to make nitrogen dioxide. So knowing this, my nitrogen and my oxygen combining together requires 180 kilojoules. Then my nitrogen monoxide combining with my oxygen to make nitrogen dioxide, doing that releases 112 kilojoules. So I can make a map of my enthalpy. So in my map, I'm starting with my nitrogen and my oxygen, and I take in 180 kilojoules to get to my intermediates of my oxygen and my nitrogen monoxide. So this is my delta H1, which is positive 180 kilojoules. While I'm sitting up here, I'm at this high energy state, right? If I were drawing a potential energy diagram, that's the top here. Okay. And I'm gonna then drop down, right? I've added my two together. Now I'm adding my nitrogen monoxide with my oxygen, and it says that I release 112 kilojoules. So that means I go down in energy. So this is my delta H2, which is negative 112 kilojoules. And then I end up at my product of nitrogen dioxide. So now I've ended up here at my product. So I've dropped down in energy. I noticed that the difference between 180 kilojoules up and 112 kilojoules down is 68 kilojoules. So my delta H for my reaction is 68 kilojoules, and I get that by adding up my two parts. So I can say that my delta H for my reaction is equal to the sum of my parts, my H1, plus my delta H2, my H1 being my 180 kilojoules, my H2 being my negative 112 kilojoules, to get a total of 68 kilojoules. So by adding these two up, I get my delta H, my reaction, which is 68 kilojoules. So looking more closely at delta H, I can reverse my sign on delta H if I need to reverse my reaction. And I can multiply a reaction by an integer so long as I multiply my delta H by the same number. So if we go through an example here, I have two forms of carbon, which are graphite and diamond. Using the enthalpies of combustion for graphite, which is negative 394 kilojoules per mole, and diamond, which is negative 396 kilojoules per mole, I want to calculate delta H for the conversion of graphite to diamond. So my overall formula that I'm trying to find, or my reaction, is going from graphite to diamond. So that is my C of graphite going to the carbon that's in the form of diamond. And this happens from combustion. Remember that combustion is just adding oxygen and it's burning. So they're combining together to make carbon dioxide. So if this is my initial reactants and products, and I know my steps in between, I can look at the pathway I need my steps to go And then if I need to multiply or reverse things, I can do that, and I also do that to my delta H. So looking at my pathway and what I have, I'm starting with graphite, so this is where I'm starting. So I need to go from my carbon of graphite, which I see reacts with oxygen, and that's going to make my carbon dioxide gas. And to do that, that's negative 394 kilojoules. From carbon dioxide, I need to then get to diamond. And I look at this reaction here, and if I go in the opposite direction of the way it's listed, if I go from carbon dioxide to my diamond, plus O2, that's going the opposite way it was, so I'm going in the reverse direction. Remember, if we reverse the reaction, we change the sign on delta H, so this is now positive 396 kilojoules. My oxygen goes in as a reactant and comes out as a product, so that cancels out. And my intermediate in between, and I notice that I've gone from my graphite to my diamond, which is the pathway that I want. We could map that out like we did above for our nitrogen dioxide. Starting at graphite, with my oxygen gas, I go down in energy, right? I go down in energy, negative 394 kilojoules, down to my intermediate of carbon dioxide. From my intermediate of carbon dioxide, I want to go to diamond, and I'm reversing the reaction so that changes my sign. So I'm going up 396 kilojoules, so it's higher than I went down, so I go up to here where I get my C of my diamond and oxygen. So the difference between here and here, that change is 2 kilojoules. So my delta H for my reaction is my negative 394 kilojoules for my first reaction, plus my 396 kilojoules for my second reaction, which gives me a total change in enthalpy of 2 kilojoules. Remember that when I'm adding and subtracting, my sig figs reports to my last common column, and for this case it's the ones place that's in common, so the answer of 2 kilojoules would have appropriate sig figs.